So superposition sounds like a real technical and scary process. Well, let's find out just how scary it is. We're going to apply the superposition theorem to circuit analysis, and we're going to state the theorem and then list step by step, how we do this. So if we look at this demonstration, in the first step here, superposition says find the current I2 through resistor 2. So what we're going to do in step 2 is we're going to take out the source that's showing up over here on the right side, VS2, and we are going to replace it with a short. Well, you should immediately see what happens is that puts R3 and R2 in parallel and in series with R1. So the third step says we're going to find R total then and I total, and we're going to be looking from the source, VS1, into the circuit, and we have R total, source 1, equal to R1 plus R2 in parallel with R3. Okay, and I total from source 1 will equal V source 1 divided by the total resistance from source 1. So all we've done is we've removed this source, and we've created a parallel relationship between R2 and R3. So step 4 says then we're going to find I2 due to VS1 by using your current divider. So I2 source 1 is equal to R3 over R2 plus R3 divided by the total current IT source 1. Okay, so now we have determined what current 2 is. Now we're going to put source 2 back in the circuit, and we're going to short VS1 with a zero resistance short. Okay, so now we're going to have R1 and R2 tied together in parallel. So we're going to find R total and I total looking from V source 2 now, such that R total is now R1 and R2 in parallel, and we're going to add that to R3. So that I total now for source 2 is equal to V source 2 divided by the total resistance of V source 2. The next step then says we're going to find I2 due to just V source 2. We still have V source 1 removed. So I2 source 2 is equal to now R1 divided by R1 plus R2, I source 2. Now we restore the original sources, and we add I2 source 1 and I2 source 2 together and get the actual I2 value. They are in the same direction, okay? So I2 is equal to I2 source 1 plus I2 source 2. So that's all it is. It's a manipulation here where we hypothetically remove a source, short it out, calculate the resistance using the current divider rule, and then put the other source back in, remove the other one, and in the end, this becomes what is called the superposition. The superposition means that we've removed one source, then we've removed the other source, and then we've put them back together. So in this case, find the current through R2 by using the superposition theory. So we've got a 10 volt source, 100 volt, 100 ohm, 100 ohm, 100 ohm, and a 5 volt source on the opposite side. So this should make the math easy. Okay, so the first thing we do is we replace V source 2 with a short. Okay, so we do that. That's going to put R2 and R3 in parallel with each other. And we solve for current I2 superposition by using the current divider. Then we do the same thing. We replace V source 1 with a short. Now R1 and R2 is in parallel. We solve for I2 from source 2 by using the current divider theory. And then in the end, we put them both back together again and solve for the total current from each half of the relationship. Okay, in this case, find the current through R2 in the circuit, but now we have a current source and a voltage source. So in a current source, it's going to require us to do something a little different. With a current source, we open the source, and in doing so, let's go back, okay? In doing so, now this whole path disappears because there's no current. So all we're left with is any current coming from V source, 10 volts, and the drops related to these two resistors R1 and R2. So now the second part, which just like before, now we put a short across the V source 1. In doing that, R1 and R2 now are in parallel, and we can solve then with the current divider, knowing that we have our source of 100 milliamps. Okay. And this one, find the current through the 100 ohm resistor. So now we have two current sources, 30 milliamps, 100 milliamps. We've got a 56 ohm resistor and a 100 ohm resistor. So to do this, we're going to open I source 2, and we're going to calculate then the current on this side of the relationship. Okay, then we're going to open I source 1, putting I source 2 back in, and notice now we've got a current that goes all the way around the outside of the circuit. Okay, so let's stop there and take a breather and think about this, because there's a lot to be absorbed with the superposition theorem.